Hey folks, welcome to a whole new unit, except for the fact that it's going to be looking very similar to our old unit because we have our bestie, the TVM solver. The only difference here with analyzing loans versus investments is that the cash flow is different. So we're going to have negative PMTs, which we're used to. Sometimes we're going to have negative future values. Sometimes we're going to have future values of 0. We'll run through a few problems here. It should go pretty quick because you guys know the TVM solver really well. So let's launch into the first example. Lars has borrowed $12,500 at 3.5% compounded monthly. After 1 year of monthly payments of $450, he still has a balance owing. So A, in which month will Lars have at least half of his loan paid off? How long will it take for Lars to pay off his loan in full? How much will Lars' last payment be? Okay, so finally we're going to deal with that decimal place for the n. And how much interest will Lars have paid by the time he has paid off the entire loan? So let's launch into the first one. In which month will Lars have at least half of his loan paid off? So we know that the present value, the initial value of the loan is going to be 12,500. Now we're going to keep this positive, which is different from before because it's actually money that is coming to us because we're borrowing that money. Payments, we know that they are $450 a month, and again, that money is going away from us, so we're using a negative value. And the future value is going to be half. Okay, when will he have paid for half of it? So it's going to be 6,250. However, we have to have this as a negative because it is money that has gone away from us. We're borrowing this money. So initially it comes to us, but eventually we have to pay it back. So that's why we use the negative. We're making monthly payments and the interest is compounded monthly. We know that our interest is 3.5%. So we know that we're going to have to solve for n. So I'm going to call it my TVM solver as per usual. And I'm going to go to finance, however you do that, enter. We're going to skip n. We know that this is going to be 3.5. Nope, 3.5. The present value is 12,500. Each payment is negative 450. The future value when it's half paid off is going to be negative 6,250. And payments per year 12, compounding periods per year is also going to be 12. So I'm going to go up to my n and we're going to alpha enter it, and we have 14.8112815. I'm just gonna do it to 3 decimal places. What the heck? Why don't we just do it to 4 decimal places? 14.811. It was 28, so I'm going to round up to 3. So in the 15th month, at least half of the loan will be paid off. Okay, so how long will it take Lars to pay off the loan in its entirety? So let's use the TVM solver again. We're going to solve for n again, but we're going to change up some of these values. We know that the interest is still going to be 3.5%. That's what he's charged. We know that the present value, the initial, not investment, but the initial loan, we know that it's going to be negative 450 for the payment, but the future value is going to be 0. Okay, we're going to pay it off so that it's 0. Compounding periods per year and payments per year is still going to be 12. So if I change those values, so I do believe on this one, the only thing that I need to change is this to 0, And I'm going to solve again for n. So how many months is this going to take to pay off in its entirety? So we have 29.0099874. So how long is it going to take? It's going to take 30 months because it's 29 and a little bit. So 30 months or 2 years, 6 months to pay off fully. You might be wondering why I'm leaving so much space here. Well, that's for the C and D part. So, C, how much will Lars's last payment be? So we know that it's going to only take 29 plus a very small portion of the payment to be able to pay it off. So this, okay, it's going to be 0.99874 of a normal payment. So to figure out how much his last payment is going to be, we're going to take that $450 and we're going to find out what 0.99874% of it is. So we multiply it by 0.00999874. When I punch that into my calculator, I'm going to get $4.49. So he's going to be paying 450, 450, 450, 29 times. But then the last one, he's going to say, oh, $4.49. That's good enough. How much interest will Lars have paid by the time he has paid off the entire loan? Now here's the depressing bit when we're talking about loans. Whenever we're looking at interest, it's always going to be stuff that we've paid. So let's use our TVM solver. And we have the stuff and we have the information in the TVM solver that tells us that's dealing with the entirety of the loan. So I know that I can use my SUMINT formula. So I'm going to go finance and scroll down SUMINT. I'm going to say 1, comma, and I'm not going to use 29 because it's 29 and a little bit, so I'm going to say 30. Enter. So in total, for borrowing $12,500, he will pay $554.50 in interest. So, like a good applied student, I'm going to write in my what I put into my calculator, SUMINT 1, comma 30, and it is going to be negative 554.50. So he pays $554.50 in interest. And we're done.